So today I'm going to review for the mechanical energy test. Um, we did a lot of kinetic and potential energy and work problems last week, so I'm going to do some conservation of energy and some power problems, but I'm also going to kind of talk about work and kinetic and potential energy as well. But the first thing I wanted to do is I wanted to go over some housekeeping things, like I always do. So the first thing I wanted to do is talk about what is due tomorrow. So tomorrow is a due date for everyone. Okay, and I'm just gonna kind of point out the tests that are due for each section tomorrow, just so you guys have an idea of what you need to, at least, at the very least, make sure you turn in. Although obviously it does help to do the quizzes and stuff before you take the test. So the mechanical energy test is due tomorrow for the 18 and the 16-week students. Okay, so both of you guys need to have that done. The 14-week students, you guys have your application of Newton's law test tomorrow, or it's due tomorrow. Remember, tests are 40% of your grade, so that's why I really stress those, because they're a large portion of your grade. Between the test and the final exam, that's like 60% of your grade, so that's pretty huge. The 12-week students, you guys are going to take your Newton's law test, where you need to have it taken by tomorrow in order to earn full credit. And then next week, your due date is the 18th. It's still Wednesday. Due dates are always Wednesday, except for the very last one of the semester will be on a Friday, but we'll get there. The 18 and 16-week students, you guys have your momentum test. Now, the mechanical energy test is module 6, and there's 11 modules. So, the 18 to 16-week kids are definitely past the halfway point at this point. And the rest of y'all are quickly getting to that point. So even if you feel like you haven't been in class that long, when you have a 12-week class, and like the last week is final exams, so that's like that's really an 11-week class. So 5 weeks into the course, you're halfway through the course. So even though it seems like you haven't been in class that long, so it's really important that you guys are doing what you need to do to bring up your grade if it's very low, because we're kind of running out of time. So and we'll talk about kind of what you can do to improve your grade in a second. So the 14-week kids next week, you guys are going to turn in your energy test, okay? And then the 12-week kids are going to turn in the application of Newton's law test. So, the 14-week kids will be at module 6 next week, which is over halfway because there's only 11 modules. And then the 12-week kids will be there like the next week. So, we are, moving quickly through this stuff, especially for those shorter sessions. And so you guys have a lot going on. I know October always seems like the busiest month for school because it seems like it kind of starts to kind of ease. We're kind of like it slows down a little bit towards November and December, but it seems like October we're just right in the thick of things. So let's talk a little bit about late work. Okay. So I know you guys know the late work policy. Okay, 1 day late. That means you're turning it in on Thursday. Is 10% from your grade. Okay, 2 days late. That means you're turning it in Friday. That's 20% from your grade. Okay, and then 3 days late. That's Saturday, Sunday, or Monday. So those weekend days, those are, those are 3 days late. That's 30%. Okay, so let's talk about some hypothetical grades. Let's say you took a test and you turned it in 3 days late and you made 100%. Okay, you take 30 from that, that's a 70, right? You went from the very highest score you could get to a C, like barely passing. Okay. Now let's say you got like an 80 on a test and you turned in 3 days late. That's a 50, right? That's like really failing, right? That's a low grade. You went from a B, which is a totally respectable grade, to failing because you turned it in 3 days late. Okay. Now let's talk about, I've had some students, let's say you get a 50 right off the bat on the test. Okay, now a lot of the students that are getting grades like this, they're not attempting the short answer. Okay, so if your test is worth 35 points, the short answer each 5 each, that means 10 out of 35 points, that's almost 30% of your test grade, is short answer. Okay, so let's say you got a 50 and it was 3 days late. That means you get a 20. Ouch, right? Now, let's say that you turn it in 3 days late and you're just turning it in to turn it in because, you want to get your facilitate or your counselor or your parents or me or whoever off your back. And you just, you turn it in, you have no idea what we're doing. So you make a 20 on the test. Okay. It's 3 days late. That's a -10. You can't get a -10. So you end up getting a 0. Okay. At least with a 20, you got some point, at least if you gotten a 20 and you turned it on time, you'd at least get some points. But a 20 turning in 3 days late, you're getting a 0. That's just if you didn't even take it at all. Okay. And this is not my late policy. This is the Georgia Virtual School late policy. So I can't change it. It has nothing to do with me. I just have to implement it. Okay, this is what I'm required to do. It's part of my job is doing that. So it's really important that you guys are turning in work on time. Um, if you don't understand it or you don't know how to do it, ask me questions or watch the videos or something. But just putting it off to the last minute, something you don't know how to do, and then not asking for help or not getting help, that's not making it any better, right? Because then something you're probably going to get a low grade on because you don't know how to do it and you didn't ask for help, and then you turn in late, that makes your low grade even lower, right? So it's really, really important that you guys are turning in things on time and you're doing as well as you can on them, okay? I have some students that have pretty low grades in the course, and it's almost entirely due to turning in work late or not at all, which is, should be frustrating to them, and it's frustrating to me. So let's talk about some things that you can do to improve your grade. Okay, in virtual school, we have something called an ELO, and that's basically our term for extra credit. The ELOs are called extra learning opportunities. Um, and we have 2 standing ELOs in this course. The first one is test corrections. Okay, so once you've taken your test, if you miss any questions on your test, you can go back and look at them. You can look at the feedback, the individual question feedback. You can look at my feedback. You can look at whatever you need to, and you could submit test corrections. Okay, a couple caveats with the test corrections: they must be handwritten. And the reason for this is you actually learn more from handwriting things than you do if you just like copy the question into Word and paste the right answer. I want you to actually do it. So you're gonna have to scan it in, and you can get 25, a quarter of a point back. So you can get 25% of what you missed back. So it's not going to bring you up from like a 50 to a 90 or anything. But it's something. And it's, if you have a low grade or you're on the edge, anything helps, right? Or even if you have a high grade, right? And you just want your grade to be as high as possible going into that final. Test corrections is a great way to do that. Another one are the synchronous session ELOs. So each one of these weekly sessions that I do has an ELO associated with it. Okay, and so what you have to do for the synchronous session ELO is you have to watch the recording. You can come to the live if you want, but you have to watch the recording. And then if you go to the Dropbox folder, there's a whole section of Dropbox in the Dropbox folder in the Dropbox that is all about ELOs. If you go to the folder for that session, for that unit, like say there's a mechanical energy one, um, there is, for example, we'll talk about the mechanical energy one because that's where we're at now. Last week we talked about mechanical energy, and this week too. So that one will be worth 2 possible points. Okay, it sounds like 2. That's like nothing, right? But it's something, believe it or not. So there's a question in there from the first session. It says, solve this question and, send me the, upload the answer or whatever you need, upload your work and everything. And I'll give you a point on the test. Okay. And then for tonight, there's one for tonight. Same thing. Solve the question, upload your work and all of that to the Dropbox folder. And then you'll get another point. Okay. So you can get between 1 to 2 points, depending on how many synchronous sessions were for that unit. And then you just solve a problem from that session. And it's a specific one. So not only will the synchronous sessions ELOs, improve your test grade, but if you actually watch them before you take the test, I know it's crazy, but if you watch them before you take the test, that might actually help you review for the test and actually bring your test grade up a little bit anyway, right? Just from doing that. Now, it says 1 point, right? So 1 point out of 35 on a test is actually like 2.86%. Okay, so this is actually 2.86% on your test. So, it's something. It's not a huge amount, but it's not a teeny tiny amount either. It's not like 1%, like you go from a 80 to an 81, right? You go from an 80 to an 82.86, almost an 83. So it is something. And these are 2 ways that you can get extra credit in this course. Okay. And then the last kind of housekeeping thing I wanted to talk to you about was, where we are in the course. So, for example, we have 18-week students. Well, 18, 16, they're both at the same spot right now. We have 11 modules, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is taken like first week of December. Or last week of November. Let me see. I'm going to check exactly for you. Yeah, it's actually the very first day of December. So it's kind of both. It's like right after Thanksgiving. Okay. So that's the end, right? If you are in the 18 and 16 week class, you're right here. Okay, so you're close, right? If you are in the 14-week session, you're right here. You're in the 12-week session, you're right here. right? So we're close. We're all getting there, right? There's not a ton of time left. So if you're one of those people that I have students that feel like this is a game they play every semester, where you see how low your grade can get before you actually start like trying to bring it up and pass. We're there. We're at that point. You need to, start doing what you need to do well. Um, which what do we need to do well? We need to let's think of some things we can do to do well. We can I don't know, read the content. That's huge, right? There's all sorts of vocab words and practice problems and things like that. We could watch the synchronous sessions, right? These sessions I do where I like work through problems and things like that. Um, we could do practice problems. And sometimes you may have to do the practice problems more than once. Okay, because basically when you get into the test, you want to get to the point where when you walk into the test or you open that test and you see a problem, you're like, oh, I know exactly how to solve it, and you can't write it fast enough because you just you spent so much time with the material, it's just like second nature to you. Okay, that's kind of where you want to be. And if that means you have to do the practice problems 3 or 4 times, you have to do the practice problems 3 or 4 times. When I was in college, I had to do my calculus homework 3 or 4 times. It took me a really long time, but I got an A in calculus. Okay, so I did what I needed to do to be successful in the course. Okay, what are some other things you can do? You can access the course resource newsletter. Those colored buttons at the top of the course. Sorry. Um, those access the course resource newsletter for that unit. That has hints on the labs. It has, if students ask me questions, it has the questions and the answer for those. It has, if you scroll down to the bottom, it's got extra instructional videos. Some of them have extra practice problems I found. There's all sorts of additional resources down there for you. Okay. And then, of course, ask questions. Okay. And you're not going to be able to leave it till the very last minute. And, most people will not be able to leave physics to the very last minute and get a great grade in physics. It's just not, it's a difficult course. It's a lot of work and it's a lot of analytical thinking and a lot of math. And so um, it's important that you guys are working a little bit on this course every single day instead of just saving it all and doing it on like Tuesday or Wednesday, because that's going to cause you a lot of stress, but it's also maybe not going to help your grades so much. So um, if you are struggling, like what can I do to improve my grade? If you're not doing all of these things, you're not doing the ELOs, maybe try doing some of those things. We have a saying in one of my other jobs where we say, if nothing changes, nothing changes, right? So if you're doing the same thing over and over and over, and if you're still getting the same results, right? Then you got to change something. I think Einstein said the definition of stupidity is doing the same thing over and over and expecting different results, right? You've got to change something of what you're doing if your grade is not where you want it to be. Okay, it's not going to improve on its own. Okay, so that's just kind of my little soapbox, my just trying to kind of help you guys out a little bit as we're approaching, or we are at the halfway point of the semester. So now let's talk about the work or the energy unit. Okay, so last week we talked about work. Okay, and we have two formulas. We have work equals force times distance. And that formula is going to be used horizontally or vertically. And this is if you're at an angle. You see how my arrow's at an angle? And it's at an angle. So let's say, for example, was trying to explain this to my husband the other day. Let's say you have a wagon, right, and you're pulling on the wagon. Um, when you pull on a wagon, you've got that the handle is kind of at an angle, right? You don't have it completely horizontal. So you would have to use this angled formula to do to talk about see how much force or the work that you're putting on a wagon. Now let's say you have a box and you're pushing it across the floor. Okay, this is supposed to be a person pushing a box across the floor. If you're pushing the box across the floor, you're just pushing it horizontally, and so you would just use this force times distance formula. Okay, so those are kind of two different ways that you can use work. Now we have the kinetic energy formula. Something important about kinetic energy, it uses this right here. It's a squared, right? So you've got to keep that in mind. We're just squaring the velocity. But in addition, if you want to solve for the velocity, you're going to have to take the square root at some point. If you're solving for velocity and you're not taking the square root at some point, you're not getting the right answer. Okay. And kinetic energy is your moving energy. So this is energy when you're moving. If you're standing still, you don't have any kinetic energy, right? Because your formula is Ke equals 1/2 mv squared. Well, if you're standing still, right, your velocity is 0. Even if it's squared, it's still 0. And so all of this, 0 times anything is 0. So your kinetic energy is 0 if you're not moving, okay? That's going to be important when we start talking about conservation of energy. Now your potential energy, okay? This is we call this stored energy, or and sometimes they call it the energy of location, because it's got your height in there, so they call it the energy of your location. Okay, so there's the height. Okay, so so for potential energy, if you're on the ground, right, or if your height is 0, then same kind of thing with potential, with like we had with kinetic. Your potential energy is 0 if you're on the ground. Okay, you have to have some sort of height differential in order to have a potential energy. And that also is going to be really important when we start talking about the roller coasters in a couple minutes. Maybe a couple seconds, actually. Okay, so here's conservation of energy. So basically it's saying that the energy before whatever is going on is equal to the energy after whatever is going on. Okay, now it's possible that you could have kinetic and potential before and kinetic and potential after. It's possible you could just have kinetic before and only potential after. You could have just potential before and kinetic and potential after. You can have any sort of combination. So I have this here. I put the roller coaster here because I wanted to kind of show you guys the roller coaster. So, for example, here, if we are, we'll say point A is rest. Okay, that we're saying we're at rest at point A. Okay, that means if we're at rest, we're only going to have potential energy because we've got some sort of height here, but we're not going to have kinetic. Okay, now let's continue our roller coaster. We start here at rest. We go here at the very bottom. At the very bottom, we have no height, but we are moving, right? So we have kinetic energy here, but no potential. Okay, now here, we're moving, so we're going to have kinetic energy here, and we're also going to have potential energy, okay, because we have a height and we're also moving. Okay, same thing with these two spots. At both of these spots, you'll have a potential, and then you'll have a kinetic as well. Okay, so it's really important to kind of think about what's going on. So for example, if we wanted to do, if we wanted to do our conservation of energy from point A to point C, well, point A, so our before, is going to be just potential. And then our point C, right? So we had, and then our after is going to be potential and kinetic. Okay, which, so that means you're going to have more potential energy here than you have potential energy here, because here, whatever this is, let's say this is 100, okay, then that's going to have to split somehow between these two, whether it's 50-50, 75-25, whatever it is, right? Whatever this number is going to have to equal this plus this. So some of that potential energy is going to get transferred to kinetic energy. It's going to become kinetic energy, okay? So that's kind of how these roller coasters work, or the conservation of energy works, okay? So here's just like a definition. It's basically saying the potential and kinetic of the system before is equal to the potential and kinetic after. Okay, so, and we usually say of the roller coaster or of the person or whatever. We're not talking about the whole world. We're just talking about that particular system that we're discussing at that point. Okay, so here we are. Let's try and solve this guy. So let's see. It says the roller coaster starting at rest from point A. So what is the speed of the car at the bottom of the hill? Okay, so let's talk about what that means. If we're starting at rest from point A, our V0 is 0. Okay, and at the bottom of the hill, that means our, so our height 0, our beginning height is 140. And then our final height for the bottom of the hill is 0. And our final velocity is something that we'll figure out. Okay, so let's talk about that. At the top of the hill, we have potential energy, right? But we're at rest, so we don't have any kinetic energy. And at the bottom of the hill, we're at height 0. So we have no potential, but we have all kinetic. Okay, and I'm going to show you what this looks like in like math form. So you know, in case you don't believe me. Okay, so let's see what we've got here. So our formula is PE0 plus KE0 I don't really think about how this red might not show up, or the blue might not show up as well on the black, plus your final potential, plus your final kinetic. Okay, and I'm going to switch to a lighter blue for the next line, just so it doesn't freak you guys out. And so I'm going to write what I have here. So what is this? My potential energy formula is mgh. Okay, so here that's going to be my initial height. Okay, so I'm going to have mass times 9.8 times 140 plus, now let's do our kinetic. So our kinetic energy formula is 1/2 mv squared. Okay, so we have plus 1/2 m, and our velocity is 0. Okay. Now our final potential, let's get mgh again, right? So we have m times 9.8, but our final height is 0. And then my final kinetic, and that's what we're going to solve for, that v squared right there, okay, or that v. So let's see what we can do. We can cross out this because it's a 0. We can cross out this because it's a 0, right? And then we're left with, we have 1372m equals 1/2 mv squared. Okay, now I get a lot of students and they're like, I can't do this. They have mass in them. I don't have a mass. I'm done. I'm done. I'm done. I'm done. Right? Well, because everything has mass in it, right? The mass is the same the whole time. So you can just actually like divide both sides by m and get rid of it. Okay, and then we'll have 1372 equals 1/2 v squared. Okay, now let me see what I want to do with this. I should have started on the left. Oh well. I'm going to go up here and go like this. Math teachers would probably kill me for doing this, but I'm going to do it anyway. So I'm going to get rid of this 1/2. So I'm going to multiply both sides by 2. Okay, so then I'll have 2744 equals v squared. Okay, so now I can take the square root. Remember I said if you're solving for v squared or you're solving for v using the potential or the kinetic energy equation, if you're not taking the square root, you're not doing it right. Okay, so here we are, we're taking the square root. Okay, so then we have 52.38 meters per second is our v. Okay, so that's our v at the very bottom. Okay, so just because you don't have a mass doesn't mean you can't solve the problem. I had students, even in my face-to-face class, they would get a question like this, and they would write like, cannot be solved. And I'm like, why would I give you a short answer question on a test and say cannot be solved, right? Why would I do that? There's got to be a way to solve it. Okay, so that's what you do with the m's. Okay, so that was like an easy potential or conservation of energy. Let's try one that's a little harder. Okay, so in this one, we're exactly the same. Okay, we're starting from rest at point A. So our initial velocity is 0. Okay, and point A has a height of 140. Okay, and it says what is the speed of the car at the top of hill B? So that's, I'll draw it here since the green's kind of hard to see on the white. Okay, so we need our final velocity, which we don't know, but we'll find it. And then we have our final height, which is 95 meters. Okay, remember last time our final height was 0 because we started here, or we ended here, but now we're ending where we actually have a height, okay? And I'm going to write my potential energy equations. Actually, I'm going to write those in 2 different colors again, just because I think it helps. So I'll keep doing potential energy in red because that shows up, but I'm going to do kinetic in the light blue. Okay, so let's see what's going on. At point A, we already decided we had potential energy, right? Then at point B, we have some sort of height. So we also have potential energy, but we're moving. So we have a kinetic too. Now, I'm going to do a dark blue here. So just any shade of blue is kinetic because I don't think the light blue will show up on the white. So we have some kinetic here. Okay, so our formula, we're going to have on the before side, we're going to have potential energy and just potential energy. And then on the far side or the after side, we're going to have potential and kinetic energy. Okay, so we're going to have some of both. So PE0 is equal to PE final plus our final kinetic energy. Okay, so the formula for potential energy is mgh, right? So I'm going to go ahead, I'm going to put m times 9.8 times 140, okay? And then I'm going to put my final potential energy, so it's still going to be m times 9.8, but instead of 140, I'm going to put 95, because that's my height at point B. And then I'm going to plug in whatever I need to plug in for kinetic, which is 1/2 m v squared, and we don't have any numbers for that, and that's okay. Okay, now do you see how each one of these has an m? So there's a couple things you can do. You can either divide by m first, or you can just figure out what it is. You can do these numbers and then divide by m later. I like to divide by m later. That's just personal preference. But like I said, you don't have to. You can go ahead and get rid of the m's now if they bother you. Okay, then what I did is I went ahead and I took 931 from both sides. And I had to minus it. You can't divide it. But basically, I'm just taking, things that are similar and putting them together. Okay, so I'm going to draw one of these arrows again. And I'm going to have, 441 equals 1/2 mv squared. Okay, so now I'm going to go ahead and I'm going to divide by m. So then I will have 441 equals 1/2 v squared. So to get v by himself, I need to multiply by 2. I'm going to do that. That'll get rid of my 1/2. And I'll get 882 equals v squared. I'll take the square root of that, and I will get 29.7 meters per second equals v. Okay, you can also see that the last one was like 50 something, and this is 29. So when we have at the bottom of the hill, we're going to be going much faster than we are up here, right? Because and that makes sense, because when you think about a roller coaster, it goes down and it's building up speed the whole way down, and this is where it's going to be max speed, okay, or max kinetic energy, and then it's going to lose some speed as it heads up the hill, right? And then here it still have some speed, but it's not going to be as much as here. So this is, they have one where it says like, where does the roller coaster have the most speed? Or where's the velocity the highest? It's going to be down here. And then the higher the point, the lower the velocity. Okay, so like here, this point and this point, these will be faster than point B. The speed will be higher, the velocity will be higher at point C and D than point B, because we're going to go down this hill, we're going to gain some speed again, or gain some velocity as we're heading down that hill. Okay, so that's kind of how these problems work. Okay, so now let's talk about, this should not say potential energy. It's close. My dad likes to say, close but no cigar, right? It's power That's what this P stands for. It's power. Um, Power is measured in watts. Okay, and then a lot of times we actually express power in like kilowatts. You guys might see that like on your light bulbs or other sorts of things. And that's just because watts are kind of small. So here we go. Here's power. It's basically the rate at which work is done, how fast you're doing your work. The faster you do your work, the more power you have. Okay, right? Because the tinier the number is down at the bottom, um, the tinier this bottom number, the larger this fraction is going to be, right? Um, so that's kind of how we do that. It's a rate at which work is done. And the lab for power, by the way, is an in-person lab. There's no simulation. You're actually going to like get away from the computer and do something. So it's kind of neat. The power lab that you guys do is the same one I used to do with my face-to-face students, and they usually had a decent amount of time. They thought it was fun. So hopefully you guys like it as well. A watt is just a joule per second, right? Which is work is in joules, time is in seconds. And then, like I said, watts are really small, so we often measure power in kilowatts. So it's really going to be important when you look at your question. If they ask for the answer in kilowatts, you know, and you get the answer in watts, you're going to have to change it to kilowatts. Or if they, ask for it in watts, then you can leave it in watts. So you're going to have to kind of be mindful of that. Okay, so let's see what we've got here. So we have an electric motor and we're lifting an elevator 9 meters. So that's a distance in 15 seconds. So that's a time by exerting an upward force of 1.2 times 10 to the 4 newtons. And then it says what power does the motor produce in kilowatts? So it wants kilowatts. Okay, so I'm going to write what I know. I know that my distance is 9 meters. I don't know if I'm going to need all this stuff or not, but I'm just going to go ahead and write it because I don't want to have to go back and read words if I don't have to. One kilowatts. Okay, so let's look at our power formula. Our power formula is work divided by time. Okay, we don't have a work, right? So, we're stuck. We can't do anything. We're done, right? No. Okay, I have students, they get to that point, they're like, I don't know what to, and I'm stuck. Okay, look at your formula sheet. Look and see if there's anything that you have that they gave you that might allow you to find work. Okay, so here's our formula for work. It's force times distance. Okay, and so what do we have? We have, they gave us a distance and they gave us a force. Okay, so we can find the work and then we can find the power. Does that mean we have to do an extra step? Yes. But it also means the problem is actually solvable. You can't just be like, I'm done. I can't figure it out. I can't do it. Right? Always go back and look at your formula sheet and see if there's something that you can do to find what you need. Okay? So here's my work. Okay, so now I can go back and I can find the power. Okay, so step 2, I'm going to find the power. Power is work divided by time. If I needed to use the triangle, I could do work over time is power, but I don't need to use the triangle, so um, I don't need to worry about that. I was just doing that to show you. So we have this 108,000 from step 1. And then our 15 from step 2. So 108,000 divided by 15 is 7,200. Now that's watts, 7,200 watts. And remember, they wanted the answer in kilowatts, so we've got to convert it to kilowatts. Okay? So I have 1,000 watts in 1 kilowatt. So I'm going to get 7.2 kilowatts as my answer. Okay? And that's all you have to do for that type of problem. So now I've worked through, from last week and this week, I've worked through like every type. I've worked through potential energy, kinetic energy, conservation of energy, work problems, power problems. So hopefully these will help you. Again, I highly recommend you watch these videos before you take your test. If you've already taken your test and you're watching the video, next time, watch the video first, then take the test. So that's that. And this test, again, is due tomorrow for 16 and 18-week students. It won't be due till the next week for 14 students. But 18-week and 16-week students, you guys are going to have to turn in this test by tomorrow at 11:59 in order to get full credit. Okay, and it has to be submitted by 11:59. You can't start it at 11:59 and then it not finished. So if you get 75 minutes to take your test, which is an hour and 15 minutes, make sure you start your test at 10:45 in order to have time to finish it before midnight or before 11:59. Okay, that's really important, and I do hold to those because the final exam, if you take the final exam on the last day before it closes and you start it and you don't, and it switches to the next day, before you finish it, it closes it, right? So it's really important that you get in the habit now, or how many weeks ago when you started the course, that you finish the test before or by the due date. So because it'll say, like, to me, it shows submitted, and it tells me the date and the time. Okay, so if tomorrow is the the 11th, and you take it at 11:50, and you finish it at 1 a.m., it's going to show submitted October 12th at 1 a.m. and that's a day late. Okay, and you don't want a day late for taking it an hour, So and that's something I have to do, virtual school policy. So that's part of my job is enforcing those policies. So it's important that you make sure that you take your test. You schedule enough time to take it so you finish before that deadline. Okay. So good luck, and if you have any questions, please just ask me.